Laplace transformation of a piecewise defined function and a step function. So let me take an example. So that we have a function ft given as a piecewise defined function. So that's 0 when t is less than 5, and it is 3t minus 1, t is greater or equal to 5. So we want to find the Laplace transform. We know the definition of Laplace transform is the integral 0 to infinity e to the negative st and then ft dt. Since I have my ft function is defined as piecewise, so the first part, if I take 0 to 5 like this, you have e to the negative st, and then the value of ft is 0. And then plus, this goes from 5 to infinity, e to the negative st, and now my ft is 3t minus 1 dt. All right. So you can see that this goes to 0 because it has a 0 multiple. The next function is the integral. So we need to take 5 to infinity e to the negative st times 3t minus 1 dt. This must go with integration by parts. So I will take this one on the side, and as you have seen before, how we do integration by parts will explain you. So I'm taking algebraic part 3t minus 1 in the left side and e to the negative st on the right side. So the left side you go with the derivative. So first you get a 3, then you get a 0. This one will give me negative e to the negative st over negative s. And then again, if you take the integral, you get e to the negative st over s squared. You get another negative s. And then we just need to put alternate sign, plus minus plus, and go cross like this. So that gives me the integral. And in the integral, you can see e to the negative st is a common factor, so keep it outside. E to the negative st, and then remaining is 3t minus 1 over negative s, and then minus 3 over s squared. And the limit is 5 to infinity. If you plug the limit and simplify, you will get your expected answer. So when you put the limit, you can see here when t goes to infinity, this term actually goes to 0 faster than that one, right? So then the whole thing, when you plug infinity, that goes to 0. So we can just take care of 5. So when I plug 5 for t, you have a negative here, e to the negative 5t, and then when you plug t equals 5, so you get 15 minus 1, which is 14 over negative s, and then that one will give me 3 over s squared. And more simplified version gives me now e to the negative 5t, and then 14 over s minus 3 over s squared. So this is the Laplace transform of this piecewise defined function. In the next part, I will show how to convert this piecewise defined function to step function and take the Laplace transform. So we are trying to determine the step function for ft, which is given as a piecewise defined function. So my boundary is here 5. Put here 5. The right hand side of this will be 3t minus 1, and the left side is 0. So this one can be written as ut minus 5 as a step function. So then this one you are writing u t minus 5, and then the right side value is 3t minus 1, and the left side is 0. So you got your piecewise defined function written as this, and then 3t minus 1. Now we'll be taking Laplace transform of this. Let us check the definition of Laplace transform of step function. If you have u t minus c and then f t minus c, so this one is e to the negative cs and then Laplace transform of ft. Is that right? So that we will be using. So from our question, Laplace transform of u t minus 5 and then 3t minus 1 should give me e to the negative 5c and then Laplace transform of ft. So first we see what we have known. As you see from the definition, that this function here is ft minus c, this one. So we are saying that f t minus 5, because c is 5, equals 3t minus 1. So what is your ft? So ft is, you need to replace t by t plus 5. So then you get just t. So that 3t plus 5 minus 1, which is 3t plus 14. Is that correct? And that we need here, Laplace transform. Now find the Laplace transform of ft, which is Laplace transform of 3t plus 14. And we know from the given formulas, 3t will give me 3 over s squared. That means you are using n factorial over s to the n plus 1. So your n is 1. And then the next one is 14 over s. And then if you put it back here, e to the negative, sorry, this will be s, not c, negative 5s. And then you get 3 over s squared plus 14 over s. Now if you go back to the previous result we have produced from the piecewise defined function, you have the same answer. Thank you.